Hello YouTube, and welcome to the second installment of the Yet Another Web App tutorial. In the last one we left it at in creating the server and the database and helping it open and close in the app. The next stage for us is to now be able to kind of connect or add a user's collection to the app. So where we're going to store our users within the database, and also then add a couple of middlewares where when we receive requests from a client, we want to unpack that request, check that it's valid for our endpoints, check any authentication or authorization for that, and then once we've responded to that request or created a response, we will want to then sanitize our response to make sure that any data coming from leaving our backend doesn't contain any sensitive data like password hashes, for example. So to continue on, we will start with creating the users collection. To do that, we will want to actually start creating what we call a type, which is kind of defining what our user is, or what our data structure is for that user. So if we do a new file called types.ts, and in here we will define our types for the user. So by doing that, we do export interface, and we're going to call it user. It's going to define our user, and this is where we're going to say what the key values for our user are going to be. So we're going to call it. We're going to have an ID, a unique ID for that user. We're going to have a name for that user, email address or email for the user, scopes. And the scopes are going to be our different levels of permissions. So we need to define those, and we'll define those using an enum. So we create export enum user scopes. We're going to call it user scopes, and we're going to have two scopes for this demo. Base user. We're going to say define as user, and admin. And it's going to be the string admin. And then we're going to say that scopes can be a list of user scopes. So scopes, a list of those. Oh, that should be string. And then we want a salt to be a string and hash. And these two are going to, the salt and hash are going to be used for the passwords, to manage the passwords for the user. So with that created, I'll just go back to my example. My reference, we want to now go into my index where we're starting up the app, and this comment I placed here before, initialize our users collection, and that is going to be offset. Oh, bear with me. It's going to be. Here we go. DB. Oh, actually, we're going to use a function. We're going to use a function. Well, let's do that. We'll use init users collection. The reason why I say this is that we want to create, and we're going to pass it the database. So let's start creating that function. Init users collection. We're going to say it needs a database and an argument, and it's going to be a Loki database. So we're going to call it up here, so pass it through the database, and it's going to return us the users collection. The reason why I say this is because actually we want to probably perform a check when we initialize the users collection, first to say whether it already exists, and if not, we're going to create it and also create a default admin user within it. So first of all, we're going to check whether that database exists, and we do that by doing database.getCollection, and we're going to say give it the user type, so Loki knows what the objects look like for a user, and I need to import that from types. There we go. We're going to call the actual collection name users here. That's what that term is. And we're going to first double check. Right, as we've already got, we might have already accessed the database. Do we have one? If not, then let's go and create the user collection. So now we're going user collection equals db.add collection. Type user and give it the name users. What we're going to do here is define some indices, the indices for the object. So unique elements in that object. So the ID is going to be unique for each one. And also we're going to set the email. Every email is going to be unique. So you can't have multiple users with the same email. And we're going to use clone to true. So when we start querying that database, it's going to create clones of the users. Right. And now, because we've created a new database, let's create a new default user who we can sign into whilst we're developing. In a full program, you might want to create this default user, or you will probably want to feed. We're going to hard code it here, but you might want to get these variables from environment variables, or even in the config.json that we created last time. So what we need to do is create a salt for hashing our password for this user. We're going to create a password hash. We never store passwords in plain text. We hash them instead, so no one knows what the actual password is. We're going to do this. Use the PDK-DF2sync crypto algorithm. That's it, imported from crypto. And we're going to give it the password. We're going to just use it admin for now. Pass it the salt and set some variables. These are set from reading I read a tutorial through passport.js who showed these settings. Again, it's worthwhile checking what settings might be appropriate for your application. And with that, then we've created the hash, and now we want to create random UID. Again, we'll use the default inbuilt crypto library for Node.js to give us a random unique ID. And now we can create a user ID. So I've also said that this constant is the type user. We're going to say name is admin, email admin@todo.com, hash is going to be the hash so we're going to do it to string, and we're going to store it in a hex format. And the same again we're going to do for the salt. So the hash and the salt typically are buffers. To save it nicely in the database, it's easier just to put it to a string, and yeah, I've set it to a hash type of string. And then we're going to give this user scopes. So user scopes dot user and user scopes dot admin. So this user is going to be a default one with full admin rights to be able to manipulate and interface with the API once we've created it. And then user collection. Now we want to insert the user into the database. It's as simple as doing user collection dot insert. Having done all that, we can now return our users collection. So that's our users collection to the database, and that again gets returned in our initializing that REST API. Now we'll probably want to have access to the users collection throughout all the endpoints in our app, and HyperExpress uses middlewares to give us access to certain, to be able to manipulate the call as it passes through the API. So we're going to create one that actually sets up the default, what they call locals, so local variables that are always passed through the request, and we can access them as and when we are calling functions on that request. To do so, we will create the middleware just below, and we'll call it default local context. And this is a middleware, and it has a request, it does a response, and it which we won't be manipulating or using, so I've just put an underscore there because we're not going to be using doing anything with the response. We're just manipulating the request, and it's got the next function. So as a request comes in, we can then process multiple functions against it until we want to respond with the final answer. So we will call next to go on to the next part of the pipeline, as it were. So we can console log, so we can see what we're doing when we're testing out. We can say, we'll call this, let's call it the function name, default local context. And we will also return, log out the URL. So when people are making requests, when we're doing our development, we'll be able to see which endpoints they are hitting. And now we're going to go a request that has a variable called locals, and what we want to do is to actually type that locals. It's a generic type at the moment, so what we're going to do is call it a type called locals, and then we're going to go and define that in our types. So in our types, we're going to export an interface called locals. I'll just double check whether, and this is going to contain a user, and it's either going to be null, where we have no user information, or decoded, we're going to call it decoded user token. So in some requests, the user will be passing a JSON web token, and we want to be able to we'll have a middleware in a moment, we'll create it, where we'll decode that token and then put that into locals. So other middlewares can use it beyond. So then that decoded user token is going to be another interface that we'll define. So decoded user token will extend, so it's going to be a based off the user, but it's not going to include the salt or the hash, because we're going to never expose those to our client, our front end. It's also going to add an IAT number that gets created by the JSON Web Token formatter. When we create that JSON Web Token later, it adds the IAT, which is a number to specify how long that token is valid for. And we can check and say, well, if it's invalid, then the user needs to log back in. So we've got the users. It's going to be either null or decode user token, and also we're going to then pass the users collection as a local variable to be used throughout our middlewares and boot handlers. So that's going to be of type collection. I need to import that from Loki, and it's going to also, so that collection contains user data, user objects. Okay, so now we go back to our default user local context, and what we want to do now is make sure we import locals in here, and now we've got our context that typically gets referred to as the locals is also typically referred to as context, the context in which this request is being handled by. And we will set this as a default as a user as null. So we will call this middleware as one of the very first events when a request comes in, and then we'll pass it user collection equals the users collection above. So it'll always bring that into our local context. And then to add that middleware to our app, we can just do app.use default local context. So like I say, anytime a request comes in, the first thing that will fire, the event that will happen will be default local context. So we'll attach a null user and the users collection to be used elsewhere. We also need to make sure that we write next in that default context, so it then continues into the next middleware or the handler. But yeah, for this tutorial, I think we'll be mostly dealing with the middleware, and then maybe doing a ping handler to do a ping pong, just to say kind of hello world request. So now we've got app use default locals. Another one that's a useful one, and we'll start creating a folder for, we'll call middlewares, is response time. So this is typically a useful middleware to create, just to understand, you know, the performance of different endpoints in your application and where you might want to improve your response times, possibly by caching information or by changing how you might process that data. So what we want to do is import middleware from Express, because the function that we're going to create is of type middleware. I'm going to call it export constant, and I'm going to put it response time. And it's going to be middleware handler. So we're using that type at the top. Of course, that's going to have a request, response, and a next. Okay. So as before, we'll console log response time, so we know that it's going to get called, and we're going to say ask who request.ul, so which endpoint is the user requesting, and we can then do constant start. So when did this process start? We can process.hr time, and then response.on. So now we're using the response. So this middleware will start and listen out for a response. Effectively start the timer when the request comes in, and it'll stop the timer when the request goes back out. So we do that by listening for the response to be in prepare, where it's preparing to go back out to the client. So then we can work out the constant elapsed time. Time, and we're going to give it the start, and we just put the elapsed time in milliseconds, which is then just taking the elapsed time from above, times that by 1,000, plus elapsed time 1 divided by 1e to the 6. And then we can put that into the response header. So just before it goes back out, we can then report back to the client or to the end user, it took this amount of time to respond to your request on the server side. And so we do this, we can pass in the elapsed time as a variable, and we'll add milliseconds to the end. And then we can do next. Oh, we want in milliseconds. There we go. And that is our response time. So again, response comes in, this will activate, start the timer, we'll do our work. On the prepare, just about as it's about to go back out, we'll just calculate how long that time between those two timestamps occurred, and we take it and return it as the response time. So in here we can just then do app.use response time. And actually we'll put that above so we can do it at the very first, so we get the full response time from even creating the default locals. Okay, the next middleware then is maybe to do some authentication. So the request might come in with a JSON web token that we might want to decode. So let's have a look. So what we want to do is then create first of all, an authenticate middleware. authenticate is just to say, is the JSON Web Token a valid token to be accepted by our application. So this is also a middleware, so we can do export constant authenticate middleware handler, request response next, console log authenticate, authenticate URL. Oh, let's call it request. Sorry, there we go. So again, we're just saying, okay, this middleware has been activated by this request from this to this URL. We'll then set the context. So we'll say it's request.locals add locals, so we know the types that we expect because we'll have already passed it to the default local context. So we'll get those typings to help us write our code. First thing we'll go have a check for is if request dot headers authorization. So we're going to check the headers of the request. Does it have an authorization header? If not, then we'll just go to the next one. So it might be a endpoint that doesn't need authentication, and if it's a later one that does, we'll check that with the authorize function that we're going to be adding, and we can return that. If not, what we'll do then, we'll grab that authorization header and if authorization includes error. There we go. So this is saying, so we're looking for a JWT token. Typically it starts with bearer and a space and then the actual token itself. And so first of all, we just want to check, does it have bearer at the start of the token? If not, we can return response dot status 400, and we'll give it some JSON, and we'll say it's an error in valid token format. We'll put it also as we'll put a 1 there because there's a couple of other ones coming along. If we just have that as an ID, then maybe we can identify where specifically the error is. And the format there of the JSON error and data will further add later a systematic way of setting that out. It's just a way we're going to put all our responses as a error and data object. So if there was no errors, and you'll have data returned, and if there was, then the data will be null and you'll return an error. Again, that consistent formatting helps on the client side to identify what's going on, and for us to type and interpret the data coming to and from our server. So if we pass that and we go, yeah, actually the bearer's there, so therefore we trust that there's also a token associated with that. So we'll just take that authorization, we'll split on a space and pop. So we'll take the last bit, so we'll split on the space between the bearer and the token element to get the actual token. And we'll just double check, is there a token that exists? And we will then, if not, we will now return another error. I'll copy that up there. Say invalid token format 2. And now what we want to do is try and decode that token. So I'm already trying to do a try catch statement to see whether we successfully decode that token. If not, we will also return an error. So we'll do the return error response. And we'll return the message of that error. And the error, there we go, e.message, and we'll set the data as null. So that'll give us some specifics about what happened when we try to decode that error. So now we go to decoded. We'll create the actual decoded function. So we'll use JWT here. So we need to import, we need to add a new package called JSON Web Token. So we want to do add to the server JSON Web Token. And that should now install. And I believe we also will need to install some types. Just double check that. And yes, we do, yeah. So it doesn't come associated with its type, so we just need to do a dash capital D at types / JSON Web Token. Now, if I see if I can type JWT again, it might come up as a default. Oh, no, so I'll import it there because of the typings are not automatically inbuilt into the package. So JWT from JSON Web Token. So we want to verify that token against a secret that we then, like, we will encode our tokens with. So this is a good time to put a secret within our globals variable. So if we go back to our config.sample, we want to then do, let's say, maybe JWT secret. We'll just put that as the sample, and in our config we'll create one called JWT underscore secret. And here we go. We could talk about demo, and that could be any string that you'd like. And what we'll need to do is go to our globals and just update our global vars and what it should contain. So here we will now expect a JWT secret type .string, and now we need to declare an empty JWT token here. And now again it will just then proceed, open that config file, process, check that there's a token available, or secret, sorry, and then it will append it to our global vars. So now we've got to our decoded token, and now we can give it our import our global vars .jwt token secret. It will then decode that token. If all is well and good and it doesn't error, we can specify to the user that the user's context now is of that decoded token. We can use the next function. Yeah, and the last bit here, of course, we need to say that if it's all successful, it will be of type decoded user token. So that's our authenticate position. And we just need to double check. That's it. It's asking, as we've got an error up there, so there's no explicit return. So we just make sure that we return that last function there. So it's just checking that all of this has a specified return value. So that's our authenticate middleware, and we can then use, and we'll put the app.use in index.json, and we'll add our authenticate middleware. So now we've got our response time. Oh, response. So let's go and update that. There we go. let's recall that in. Response time, there we go. So yeah, we've got our response time to record how quickly we respond to a request. We update our default local context to include a user and users collection. And then of course we authenticate the request, check that there's a bearer token, and if so, we'll decode that and then update the user's object to say that this user is present in this request. Right, so we're almost there. Then the last middleware I was going to add today is the sanitize middleware. So the sanitize middleware is just to make sure that when we respond to requests, we're not going to send any data that we should not do back to our end user. To do this, we're going to create the sanitize middleware. So as before, we start creating the function. Constant sanitize. Handler. And this time we're not interested in the request because we're going to be only looking at the response. So we can just put an underscore there. And of course we still need the next function. Pass on to the next middleware. So in the sanitize, we're going to grab the response.json function from the response, and we are going to append. We're going to update that function. We're going to override it. Say that yeah, we're happy to accept any body. And if the body.data is not equal to null, so remember we've got errors in data, we're going to sanitize that data. So we're going to create a function called sanitize response object, and we're going to give it body.data, and then we're going to do JSON and call the original JSON function that we're replacing. So we're just going to do a little like middleman step there just to check before that data goes out whether it's okay. We're going to have an error up here because we're reassigning the body. So we just want to see if we can turn that out because it comes as a boot. So what we want to do is just expecting this error. So I'll just do ts expect error. But now we need to actually run this sanitize response object function. We actually need to make it. So we're going to do function sanitize object. So it already knows that it's expecting to create that function. We're going to give it an object of any, because it could be any object. It could be a list of users, it could be a single user, it could be a bearer token that we're giving back. So it could be of all types of different shape and size. And what we're going to do is check whether that object is not null, and it's a type of, oops, no, we don't need that, OS type of object equals object. So is it an actual object itself? And array is array object equal false. So basically, is it a key value pair object? If so, we're just going to go run over that object and just double check. We want to make sure we delete any the salt. We're going to delete the hash. So you can imagine that if this object was a user that we were returning and we hadn't done this, we would be returning their password hash. Meta, and there's another one called @Loki, and these are keys that come from the Loki database that keeps reference. So when we query user objects and items from the Loki database, these are already hidden. Well, I say not hidden, but they're in the object itself. So when we say insert or update, it will use those to reference, that's the specific object I want to update. Again, we don't need to send those to the end user. They're for internal purposes only. So now we just do constant O of object dot values. So once we'd removed those ones, we're just going to run through any other values in that object. And if its type of object, then we're going to do sanitize response object again. So this is doing a recursive run through of the objects that we're responding to. Objects. Oh no, yeah. And now we need to do if object again is not null and type of object again is object. And actually I'll just copy this top again. We're going to say is the array actually true, so it's just an array of items. We want to then also loop through those items and run its function. There we go. Sanitize. Oops. Object. There we go. We've got a couple of errors. Am I missing here? That's it. Yeah, return as implicit type any. That's okay. Because yeah, we're going to not return, we're void. We just call it. It's because it's an array function. I've called it a function. Sorry, apologies. So it's a constant sanitize object. There we go. Yeah. So this, yeah, we're using an arrow function there, not an all function. So there we go. That's going to be basically looping through our response objects, checking that any of these keys exist. If they do, delete them. So we've kept it nice and clean. And that then can also be use. Again, we need to probably put that above any time where we might respond. So let's put that because the order in which we add them is almost like the order in which they get called upon. Sanitize. There we go. So it's going to clean up any potential responses. Great. So now we can actually start, like say, by even just creating a single endpoint. I think that's a good way to stop here. Would be just to do a ping pong kind of hello world back and forth between the client, between like say the website endpoint and the REST API. To do that, we will create a router. So these are like once we've passed through all these middlewares, we will then end up at a route that we want to then actually do some work against those against the data that we're being requested for. So we'll create a new folder called router or routers. Oops. Let's rename that because we're going to have multiple ones. We're going to have just this ping one. We're going to also have users, and we're going to have to-dos. So we will create the ping.ts for the ping router, and we're going to call it. So we're going to create a function called const ping, and it's going to be a user route handler. So this is going to actually, like say, handle the route request at the very end. We're going to call it. We're going to have it as an async operation. We'll see why in a moment. And it's going to take a request and response. Okay. So what we've got here at the moment is a request that hasn't got its locals defined. We've done that in past in the middleware by saying set the context as locals. It doesn't define in or restrict us on type of the JSON that we can respond to, but we want to type it with errors and data. And we also want to then kind of wrap up and have a nice little send request. So we can send with a status code and the data in just one nice little function. So to make it, it's more of a kind of convenience function this. So to do this, we are going to create a function within our types called types are, and it doesn't also tell us what arguments we've expected from the end user. They might be like they're logging in, so they need to provide us with an email and password. When we look at the request, the TypeScript doesn't know whether to expect login or email in that request. So we need to, add that functionality in. To do so, we are going to create this function called, I've called it, and I'll put it in the types file because it's more kind of a typing function. And we're going to call it type the args, the arguments coming in, the context that we're receiving the request in, and a send, how we're going to respond to that request. And we're going to be able to specify the args, or we'll set that to unknown if it's not defined when we use this function. And it will expect a request, just a type request from type request down there. It is of type response. Oops. Yeah. So I need to. There we go. We import the type response from a request, and the function will return a object with the args, and this is where the await needed it, because we're going to await, and we're going to unpack the JSON object. We're going to expect JSON objects from our requests. Everything we're doing is JSON back and forth. It's going to be of type args, so we will give it this function what type it is for the different calls later on. At the moment we're not going to be using it, but you'll see that in the next tutorial. We're going to define the context, which is what we've done before, is request.locals, locals, and we're going to define a send function, which is just a wrapper. Again, for convenience, it's going to have a status number, status, which is going to be a number. The JSON is going to be of a type called we're going to call response body. So this is what we're going to help us just make sure that we're always sending the responses in the format that we wish to. So we just need to define that. So we do export interface response body, and it is create null and data of any. So that's what it wants to, it's fundamentally going to have an error and a data object attached to it. We will then return response.status with the status .json to JSON. So that's our convenience function defined. Now let's just clean up our. Yep, I want to. Oops. Yep, here we go. Okay, clean up all the editors. And then we go back to our ping, and that's the first object we're going to put into our ping. So we are going to constant unpack that convenience function. We just only need the send from it. We're going to await, because we need to await for the JSON to unpack if there was any JSON to unpack, that is. Type args. Oops, we need to equals, of course. Await. Type args. Send. There we go. It'll all do. And we'll give it the request and the response. And what we're simply going to do is going to respond to that request with a send, with our next convenience function send, with our data object of error null. And we're going to do the data string pull. And now, so we've got this function that we want to now attach to an endpoint for our REST API. So what we want to do is now create a router to join all these dots together. So we're going to call it ping router. It's going to be a new router from HyperExpress. With that ping router, we're going to listen for any GET requests on the endpoint ping, and we're going to give it that function ping. So it's going to go, so imagine we're hitting this endpoint ping, it's going to run through our middlewares, and then HyperExpress to recognize, /ping is recognized, is connected to this function. We'll call this function as the final step in the process. So now that's our router declared for a simple ping pong interface, and they're quite often useful to have anyway in REST APIs, just to check that it's your API is functioning and you're able to access it from your local host or from the web. So now what we want to do is now connect that up to a endpoint on the app. So app.use, what we're going to give it is on the API, so it's going to be like localhost /API, then /ping. We'll give it the ping router. So there we go, and that should have automatically imported. So we've got our ping up there. So that will then respond to any of those ping requests, and I believe, if I haven't forgotten, that will complete the session. So what we've done today, we've created the user's collection, defined our user, we've created a bunch of middleware to do response time, to sanitize our objects being returned. We've added a default local context that allows us to have a user and also have access to the user's collection, so we can use that throughout our routes. And the authenticate to make sure, like, if the user comes with a bearer token and it is correct, it's of a type JSON Web Token, and it passes our secret, that will unpack it, and within that should be the user data that we can then again use at the endpoint. And then we've created that ping router endpoint. So now we want to see if this all works. So if we remember back from the previous previous tutorial, we did start.server. From the workspace, we created that function to be able to boot it up. It's looking all good. There we go. So it's all booted up. We've got running a server. It's running on local host. We've got VS Code recognizing that that's occurred. If we go to our temp directory, we have also created a database.json. Because we've now added a collection, it's recognized that, and it's created a persistent store. And in here we can see our data for our admin user, our default user, and the codes. And if I now go to bring over a web browser, bring that across, API ping, and there we go. See, what we've got is the 3000 API ping, and we get pong, our data being returned. There we go. So that's our second tutorial. We have now done all the middlewares, API endpoint. We're now getting to the stage where actually we can get to creating users, logging them in, registering, and that'll be all in the next episode. So thank you very much for watching, and look forward to seeing you in the next episode.